Hello everyone, welcome to our 20th video in the Python for Artificial Intelligence and Machine Learning series. My name is Dheerajchoudharyailab and today we are diving into object-oriented programming, which is known as OOP in Python, which is where we are going to specifically focus on classes and objects. So this is a fundamental to modern programming and is especially useful for structuring complex artificial intelligence and machine learning applications. Understanding OOP will help you work with many popular machine learning libraries and design your own efficient and maintainable code. So let's first understand what exactly is object-oriented programming. So it is a programming paradigm that organizes code around objects rather than actions and data rather than logic. In OOPS, we combine data, that is the attribute, and behavior, those are the methods, into a single unit called a class. Classes serves as a blueprint for creating objects which are instances of these classes. So the four core components of OOPS are classes, objects, attributes, and method. This organization makes the code more modular and easy to maintain. In artificial intelligence and machine learning, OOP is particularly useful for structuring complex models, encapsulating data processing steps, and creating reusable components. As well as we will see throughout this video how OOP provides a natural way to model real-world entities and concepts, which is especially valuable in artificial intelligence where we often try to mimic real-world use cases and scenarios. So let's understand that what are these four components which the classes are made of. So if I go to our code editor, so these are the basics of basic core components. So as we said that over here, the first core component is constructor, second core component is the methods that we use. So this is initializer method, this is the class attribute, and this is the method that we define inside it. So I told you as part of the definition where what I was saying you that it serves as a blueprint for creating objects which are instances of these classes. Okay, and as part of this we will see classes, then we are going to see the attributes that you can see over here, how we define the attribute in the classes, and then the methods. So that is how there is a structure of OOPS that we follow for the coding. Now let's go ahead and understand classes and objects in detail. So in Python, a class is a blueprint that defines a new type of object. It specifies the attributes like data, methods, behaviors that object of that type will have. So when we define a class, we are creating a new namespace, establishing a template for our future objects. So let's correlate that with our example. So when I say that when we define a class, so first we have defined a class, that class name is animal. Okay, so we are creating a new namespace. So animal is our new namespace and we are establishing a template for our future objects. So right now, as part of this template, I have only one method which has been defined, that is the behavior of that animal. So this is not only one of the behavior of the animal, there can be multiple behaviors of the animal that you can add. So this is just a blueprint. Inside that, multiple methods can be added later on. So objects, on the other hand, are specific instances of a class. Each object created from a class has its own set of attributes and can perform the behavior defined by its class. What does that mean? So once you create your class, okay, then after creating your class, when you have to use that class, at that time what you do, first you will have to create an object. Every object that you create can be instantiated separately. So first, when I say dog is equal to animal buddy, over here I have passed the name attribute, which is going to be self-initialized by the initializer constructor inside the class, and it is going to be available for the entire code inside this class. So whenever I say dog is equal to animal buddy, it is creating a new instance, that is a new object with its own value. So first time I am saying buddy, second time I will say Jasper, third time I would say some other animal's name. So every time I'm using another animal's name, I am creating a new object with my customized attributes that I want to pass inside that object. So this ability to create multiple objects from a single blueprint is one of the key benefits of OOPS, allowing for code reuse and code organization. So let's break down the simple example that we have. So in this example, what we are doing, so first we went ahead and we defined a class. Once we defined a class, then this class is going to be the blueprint. Now inside this class, we are declaring a class attribute which is known as species. Consider class attributes as a global variable which will be available for any of the methods which are defined inside the class. They can call it and they can use it. Otherwise, whenever you can, global variable, whenever you create an object dog, so this goes ahead and get triggered. So if I go ahead and run this code, so once I create an object dog, what I'm doing is I'm trying to say dog.species. So over here you will see that how this value is being made available for each and every object by default. So whatever object I'm going to create, every object is going to have this class attribute. That is how class attributes work. Then the init method. So it is the initializer. It runs every time you create a new animal, that is a dog, and it takes the name as an input and store them as an instance attributes using self.name inside it. And we also define an instance method over here. This is the instance method which is known as def_speak. Okay, so when we invoke this instance method, it is going to return, or no, sorry, it is going to print this value for us. So when I said dog.speak after creating the object, so our object was created for buddy, that is, so when I said dog.speak, then the object that we created with our specific attribute, so that value was used over here, and we got the output as buddy says hello. So this is how you can use classes, objects, and class attributes. Now let's do deep dive into creating classes. So how you create classes exactly. So let's understand that with an detailed example. So this is our example of rectangle. So what we do to create class in Python. So we start with the word keyword, that is class, that you see over here. Okay, followed by a class name and a colon. Then after that comes the class body, which contains the attribute method intended below this line, which I already showed you in my previous example. Now, by convention, the class names over here, that is this class name, it uses a camel case where each word of that class is initialized, it's capitalized for the first letter, and they are joined without spaces. While the methods and attributes that we defined, so over here, these are the methods: def init, def area, def parameter. While the methods that we use over here inside this class, these are going to be words which are going to be in lowercase, and these are going to be separated by underscores. So that is how the naming convention is followed for the methods which are defined inside the class. Now, a class has different types of attributes and method. Okay, so different types of attributes and method, we will go in depth about different types of method, but for now in the current example, this is different types of attributes. So this is one type of attribute that we have written, that is shape type, which is quadrilateral. This is going to be our constant attribute that we are using over here. Then after that comes the initializer method. That is one of the method type that we use. Okay, so the class attributes that you see over here, that is shape underscore type quadrilateral, it is going to be shared by all the instances of the class, while the instance attribute are unique to each other. So methods are functions defined within the class that describes the behavior of objects. The special init method that you see over here, that is the initializer method, is known as the initializer or constructor. So till now I was calling it as initializer. It is also known as constructor, and is called when an object is created and is typically used to set up initial attribute values. So when I say dog is equal to animal buddy, what happens? It goes inside this code before. So this code starts running. As soon as this code starts running, it is not going to run this method automatically till the time I am not going to call it. So at the top type of object creation, every instance of object, this code is going to run. That is the constructor or initializer. That is the init method, which is going to run always. Okay, so over here in this example, what we have is, so we start with a class named rectangle. So as per our class concept, what is this? This is going to be the blueprint for creating a rectangle objects. Now our blueprint is created. Then I have used over here docstring. You can also provide a docstring with a triple quote by using which it makes your code more readable, where other person will understand that what exactly this class has been created for. After that, I'm going ahead and saying shape is equal to quadrilateral, and this is the class attributes. So all rectangles share this specific attribute, and it says that every rectangle object that we are going to use is going to be quadrilateral, that is a four shaped. That is how a four shaped quadrilateral it would be. After that, we are going ahead and defining our init method. So this is the initializer method, and it is going to run automatically whenever we are going to create a new rectangle. Every time we create a new rectangle, it is going to be created, and it is going to take the width and height as input. So over here you can see width and height as input. After it takes the width and height as input, then we are defining our instance attribute. So while defining our instance attribute, so each rectangle objects are going to store its own width and height. So self over here means that these value belong to that specific rectangle, means every instance of class object that you are creating. After that, we are defining our instance method, which is area. Okay, so this is going to calculate the area of a rectangle, and it uses the stored width and height that is being there from the initializer method. Okay, and over here it has to do width into height, and this value of width into height is going to come from our initializer method, where self dot width is equal to width and self dot height is equal to height was that we created, and we are using it over here to get the area of the rectangle. Then we are going ahead and defining parameter. So this is another instance method that is going to calculate the parameter of rectangle, and the formula over here is 2 into self dot method plus self dot height. So this is the formula for getting the parameter of the yeah, get the parameter. So that is how you can define different methods as part of the class. So in short, in this example, what we understood is we defined a rectangle class, that is our class blueprint. Then we went ahead and created a class attribute, that is a shape type. Then we created our instance attribute, that is width and height, in the initializer method. Then we went ahead and encapsulated other methods also as part of it. So over here, after this initializer, okay, this two instance methods are the behavior. So these are the two behavior for which we have actually gone ahead and created functions for inside this class. This is how you create a well-structured class, where you have your class names, you have class attributes, you have instance attributes, you have methods, you have special methods, that is init, and you also have to follow the convention of using camel case for the class name and snake case, that is lowercase with underscore, for the method's name that you define. Now let's go ahead and talk more about class attributes versus instance attribute. So in Python classes, there are two different types of attributes, which we have already seen, but let's go in more depth. So class attributes are defined at the class level, that is outside any method. So if we go back in our previous example, this is class attribute. You will see that this is not inside any one of them. It is like a global one, that is known as class attribute. Okay, and they are shared by all the instances of the class and can be accessed using either the class name or any instance. So if you want to access that specific attribute from that class, what you can do is you can say class name. So our class name was rectangle, so it would be rectangle dot shape type, or it will be instance dot attribute, that is the instance that we have, that is area. Okay, instance methods. So that is how we can go ahead and we can use it as a we can access it. Now, so class attributes are useful for defining properties that should be same for all the instances, like constants or default value. And instance attributes, on the other hand, which we are going to talk now, are defined within the methods, which is typically in the limit of method itself, and they are unique to each instance and are accessed via the instance name only. And the instance attributes store the data that varies between different objects of the same class. So for example, when I say if I go in the first example, when I say dog is equal to animal buddy, this is instance 1. Next instance, when I say dog is equal to animal Jasper, it is a new instance. So every time I am passing a new instance, So right now over here we have not used the instance attribute, but usually the instance attribute changes for all of them. So first time when I'm going to create it, at that time I'm going to pass the value 5 plus 2. Second time it would be 10 plus 10 and 2, right? So every time a new object is going to be uh, using different values. So they are unique to each instance and are accessed via instance name, as we saw. And instance attributes store the data between different objects of the same class. So understanding the difference between two of them is crucial for designing effective classes. So let's now see in-depth example of class attributes, and also we are going to see example of instance attribute. So in this example, class car is a blueprint of creating the car objects. Okay. Then we are saying wheel is equal to 4 and vehicle type is equal to automobile. What are these? These are our class attributes. As I said, these are constants or default values which we are going to use throughout this class. Then I go ahead and I define the init method, that is our initializer or constructor, with 4 parameters where I have make, model, year and color. Okay. And it runs whenever you create a new car object, and it takes make, model, year, car, color as inputs. So every time I am going to say, so first time I will say civic is equal to car, then I am passing these values. Okay, so these are the same 4 values that I am passing. So every time a new object is going to create, it would be created it would be creating different instance. First instance would be for civic car, second would be for Mustang. That is how it would be different for each one. Then inside the def init, what we are doing is we are now going ahead and creating our instance attributes, and what they do is they store information unique to each car. Like in Civic and Mustang, both have different makes and colors. So one is from Honda, one is for Ford, right? So it is going to help you to define different values for each object. Now over here you will see that self.mileage is equal to 0. So this is going to set the mileage for every car object to 0 as a default value that you have defined. So every new car is going to start with 0 miles driven before creating the object. And while creating instance, what we are doing is Civic is equal to car, Honda Civic 220 and silver. This is going to create a car object named Civic, and the second one is going to create a car object named Mustang. Okay. Then when we come to the print values, now I will show you how you are accessing your class attributes and how you are accessing your instance attribute. So first, when I say print car.wheels, it is going to show the wheels attribute directly from the class. We have not defined it while we are creating the object. It was already there as a default value, where the output is going to be by default 4, because I have defined wheels is going to be 4. So every time it is going to give us the output as 4. Second time, what I did is, first time I am calling it in the first way. I showed you in the last slide. One you can call with class name dot the attribute, and then you can also call it by instance name dot the attribute. So I am doing it, I am calling the attributes in 2 ways. First one is car dot wheels. So that's why it gave 4, and second time again I am calling it for the specific object, that is Civic. Over there also the default value is 4. Now let's see how you can access instance attribute. So over here we are doing print civic dot make. This is going to show Honda because the make for the Civic object is Honda. How it got that make? Because when we created this object, we passed these parameters which went to our initializer function over here. Okay, and this is setting the value for make, model, year and color as self.make, self.model, self.year and self.color. And that is how the value of this instance attributes were stored for that specific object. Then in the next one I say Mustang.make, the same way. It is referring to the another object in which the values were defined, and it was initialized by our initializer function, initializer method over here. Now, what are the key takeaways that we saw over here is the class attributes that is on the top that we saw. These are shared by all the cars. Example wheels, it is 4 wheels are going to be for all the cars, and for instance attribute, it is going to hold specific details of each car. So you can access class attributes for the from the class or an object, as we saw. Now let's go ahead and move to our next concept. So next we are going to talk about method in classes in more depth. I already showed you that how we are writing our instance method, but there are other methods also, different types of method that you can define. So methods are defined within the class as we saw, and it describes the behavior of the object. So in our first example, when I say def speak, this is a behavior of the animal. Speaking is the behavior. Okay. Now, so the most common type that we use in classes usually is instance method, which is going to operate on specific instances of a class, and it is going to take self as their first parameter. The I hope you remember that in our from our previous example we were using self.make, self.year. So those are the self parameters that we were defining. Then class methods. What's the difference between instance and class? So class methods actually operate on the class level rather than the instance, and are defined at the and are defined with @class method decorator that I will show you. So this is how it is defined, @class method. So this is the decorator you will have to use whenever you define a class method, and this is on the class level. The statics method don't operate on either instance level or the class level, and it is defined with the @static method decorator. So this encapsulation of different behaviors with the data they act upon is a key advantage of object-oriented programming, making the code more intuitive and maintainable. So let's understand all these different kinds of method with example. So in this, I will also show you that how we are creating them and how we are accessing them also. So this is a big use case. So stay with me. First, what I am doing is, first we say, we start by defining a class bank account. This is going to be our blueprint for creating multiple account objects. Then I go ahead and create class attribute inside the class where the interest rate is set to 0.02. That is 2% interest rate. And this class attribute is shared by all the bank accounts that you see inside this specific class. Then we move to the initializer method, which is this. So in our initializer method, what happens over here is it runs every time we create a new account. Whenever we say object is equal to class bank account, while initialization, when I say account 1 is equal to bank account and I pass this account number and balance, every time it is going to run. Okay, and it is going to set these two parameters for us, that is account number and balance. So account number is optional, and the balance that you see over here is equal to 0. That means it has given a default value. So and the default value over here is 0. So it is also optional, but if you're not giving any value, by default it is going to take it as 0. Now moving to the instance method. So in instance method, what we are doing is we are now going to work on one specific object at a time. So the first one is deposit method. What deposit method is doing over here is, let me highlight first. So it is going to take an amount and it is going to check if it's positive. If it is positive, it is going to go ahead and add that to the account balance and it is going to return true. Otherwise, it will return false. That is the logic we have used over here. Now, the another instance method that we have used is a withdraw method. Withdraw method. In that, what we are doing is it is going to check if the amount is valid, which is more than or greater than 0. And less than the current balance, and if so, it will subtract it and it is going to go ahead and return true. So we will say that I have withdrawn 100 rupees from my account and my total account balance was 500. So it is going to give me in return the value of 400 after subtracting it. Then the other one, that is the instance method, is add interest method. It uses the shared interest rate to add interest to the account's balance. So shared interest rate, where it is, this is the interest rate. So it is going to use that class attribute based on which it is going to add that interest to our account. Then for last method, instance method, is going to be balance. So it is going to return the current balance for that account. And all this method uses self, so they work with data for that account only. Nobody is having their own different attributes defined inside the methods. Everyone is using self. So whenever we call a class and the first value that is going to be passed, like 1 2 3 4 5, account number and 500, it is going to be used by all of them as an instance method. Okay, now let's talk about class method. So as I said, it is being marked with @class method, that is the decorator, and it takes CLS instead of self. So for other instance method, it takes instances, right? But that is the self values that we have available, but this one takes CLS instead of self, and it can change the interest rate for the whole class. So all the accounts will use the new interest rate. So what we are doing over here is, uh, if you call this method, it is going to change the interest rate that we have defined over here. So this usually works on the class level when you want to make the changes to the class level class attributes. Then the static method. So in static method, this is marked with @static method decorator, as we saw, and it doesn't use self or CLS, that is instance or class, and it is just going to print a general message that all account must maintain a minimum balance of $100. And it's like a helper function that belongs to the class but doesn't need to access or change any data. It is a constant value which is going to be throughout. Then once we have defined our entire class with all these three methods, I will go ahead now and I will show you how we are going to use these methods. So over here, what is happening that when I say account1 is equal to bank account, it is going to go ahead and it is going to run the initializer method over here, where the account number is going to be passed over here, which is going to set over here, and the balance will be set over here. So the account number 1 2 3 4 5 will come as an argument, and balance will come as 500. Then we are creating self dot two parameters, that is self dot account number and self dot balance. Once we create both of them, so these values which has came as an input, it is going to be available now for all the instance method. And now by using this value, we are going to perform our operation of deposit, withdraws, add interest, and get balance. So in our example, if I go ahead and run this first, what will happen? First, I am going ahead and saying account is equal to bank account, where initializer function has saved these values. Then second, I am going ahead and saying account1 dot deposit. So when I say account1 dot deposit, at that time I am saying that I am going to deposit 200 rupees into this account. So our our method is going to return the addition of 500 plus 200, which is going to be 700. Then when I go ahead and say account 1 dot withdraw, so now from 700 we are going ahead and withdrawing 100 rupees, and that's how your balance becomes 600. Now the third time, again we are going to use our third instance method, where I'm going to add interest on the 600 rupees. So what I'm going to do is account1 is dot add interest. I don't have to mention the interest because that is our in our class attribute, which is a constant value that we have already passed. That's why you will see account1 balance has become 630, because we have an interest added to it. So that is how you can use your instance method that you have defined. Now the second method is the class method. So as I said you that in our class method, what we did is in our class attribute, we have set the interest rate as 0.02, that was 2%. But now by using this method, we are going to change that value. And when I go ahead and say using class method to change in over here, when I say bank account, the object bank account, so we are saying class name dot set interest, that is the attribute name, and we are passing the new value. It is going to go ahead and change the value for our class now for the entire class. Then after that, when I'm going to go ahead and create a new object for by using the same class, this time it is not going to use 2%, it is going to use 5% interest. That's why second time the interest you will see is 1050, that is 5% extra when we are going ahead and adding the interest. Now we want to know what are the bank policies which are constant, or which are the recently updated. So for that, what we are calling the static method. Again, to call the static method, you will say the class name dot bank policy. It is going to just return you what exactly you have mentioned over here. So our static method says that all accounts must maintain a minimum balance of $100. That is how you use different types of methods. So in short, the instance method uses self to access or change data for one account. Class method uses CLS to change data that affects all the accounts, and static methods are going to provide related functionality that doesn't need to be touched by any data. So this is how these three behave, and this shows how powerful OOPS is and how you can group related data like balance, account number, and the behaviors, that is deposit, withdraw, policy all together. Let's go ahead and see what's next. So now let's deep dive into init method, because it is a special method in Python classes that act as a constructor. It's automatically called when an object is created from the class, and it is used to initialize the instance attribute, which can be used by all the methods, that is the instance method inside the class. The init method always takes self as its first parameter, which refers to the instance being created, followed by another parameters which is needed to initialize that specific object. While not strictly required in class definition, the init method is very commonly used because most classes need to set up initial attribute values. And it's important to note that init does not return a value. It's called for its side effect of initializing the object. It is not going to do any behavioral job for us. It is just a constructor to set the metadata, I would say in short, for the specific program that you are building. So now let's understand this by one good example. So the init method. So over here, what we are doing, first I am going to go ahead and create a person class, which is a blueprint for making person objects. Then I am going ahead and I am defining our constructor. So it is going to take three parameters, that is name, age, occupation, and the occupation we have defaulted to none. So these are all the parameters that we are going to take. Okay, and this shows how both optional and required parameters are been required over here. So we have, this is optional, right? And these are the required parameters. Name and age are the required parameters that needs to be passed when you want to create an object of this class. Then we go ahead and say self.name is equal to name and self.age is equal to age. These lines are going to create the instance attribute, and they will store each person's name and age unique for each object we are going to create by using this class. Then self.occupation is equal to occupation. What it is going to do is it is going to create another instance attribute, and if no occupation is given while we are creating this object, it is going to stay as none. So it is not, that's why it is optional one. Then we say, then we go ahead and say that self is adult is equal to age is greater than 18. So this is a derived attribute that we have used over here, which calculates if the person is an adult based on their age. And this shows you can do calculation or check, perform some checks during the initialization of creating your object. And it is not just your store inputs. Then comes the instance method that we have defined, which is def introduce. So it uses the person's attribute to return a short introduction. If the person has an occupation, it adds that info to over here. So if I say if self.occupation, if it is available, it is not none, it will say inside that intro, it is going to go ahead and add, I work as a freelancer, I work as an engineer, I work as an ML engineer. So that is how it is going to concatenate the value over here inside with your occupation along with your name and age. Okay, now next what we are doing is we are going ahead and we are creating instances. So first we are creating the object Alice, where we are passing the value Alice, 28 and engineer. If I go ahead and run this, so you are going to get this value where we say, see, hi, I am Alice, I am 28 years old, and I work as an engineer. Now you'll be wondering that how come this value came with this? See this. So we have concatenated the string that has been saved in the intro variable, and we have added a new line at the end uh, of this intro that has been created over here. So that is how it has been done. Then this is specific for Alice object. Second time I am going ahead and creating a Bob object. So over here you will see that it is not going to go ahead and concatenate this, because if we are not passing any occupation, it is going to be none object. That is the reason it is saying, hi, I am Bob and I am 17 years old, and this hasn't been modified. Intro hasn't been modified because the occupation is none. So the key takeaways is it runs automatically when you make a new object. Every time it will run for every new object. It sets up the instance attribute for required and optional data, and you can calculate or check values to create derived attributes that we did. Okay, and you have to make sure that every object starts over here with appropriate values. So when you're passing these values, you have to make sure you have to understand which are the mandatory ones and which are the optional ones, so that you don't get any error. Now let's see what's next. So next we are going to talk about creating an object, which is also known as instantiating a class. We have done it a lot, but this time we will do deep dive in it. So while creating an object, what we are doing is we are calling the class name, and if it were a function with any arguments needed by the init method, this creates a new instance of class with its own set of instance attribute. So in our last example, Alice is an object that you are creating for person class, and every object that you create is get created with the new unique values that you are passing as an argument while creating that specific object. And this every new value that you're creating, this creates a new instance of the class with its own instance attributes that you're passing as an argument, and you can create multiple objects. So right now you saw that we created person class one time, and we have created multiple objects. So Alice is one object and Bob is one object, class one, object multiple. And these objects can be stored in list, dictionaries, or data structure for easy management. In machine learning application, you might create objects to represent different models, datasets, or pre-processing steps, and then iterate through them for evaluation or comparison. So this is going to be an advanced version of what we were doing over here. So what we are doing over here, you will see that we are going to loop with the multiple objects that we create. So let's go ahead and understand this code. First, we will start by defining a class called product. This is going to be our blueprint for creating product objects that have name, price, stock, and quantity. So over here, if you will see, name and price is required, stock is optional. Okay. So then we go ahead and talk about our init. So this is an initializer method, that is a constructor, and it is going to run every time when we create a new product. It is going to take the name, price, and the required values, and stock as optional with default of 0. And when we say self.name is equal to name, self.price is equal to price, self.stock is equal to stock, these lines set up the instance attribute, and each product is going to keep its own name, price, and stock quantity whenever you are going to go ahead and create a new object and pass new values. Now let's talk about the instance method. So the instance method that we have over here is total underscore value. So this is going to calculate the total value of the product in stock by multiplying its price by how many times, by how many items you have. So it is saying self.price into self.stock, price of an item into stock of an item. So if I have one piece of laptop for 50,000 and I have 5 of them in stock, so 50,000 into 5. Then we are going ahead and creating multiple objects. So this time the object that I'm going to create, so previously the object that I was creating, see, it was a one-liner object creation and getting saved into one specific variable. But this time what we are doing is we are using product class and we are creating 4 objects, and those 4 objects we are saving as list. So when I say product laptop 1205, this is the first object which will get created. So this values the value of this. So the value of the object will be returned over here. Same for phone, headphones, and tablet. Once it is been written, what we are going to do is we are going to use a loop, and first we are going to before calculating the total inventory of all the objects that we have, first we will set a default value of total inventory to 0. Then we are going to loop through each product in the product list, that is product.total value, this one. So how it works, so for product in products, so this is the product, the list. First it is going to go ahead and use this variable in which it is going to pick all the product one by one. So first it will pick laptop. Once it is going to pick laptop, then we are getting the total value of that laptop. So when we say value is equal to product.total value, it is going to give us the price, that is 1200 into 5, and it will be stored in value. Then we go ahead and print product dot name and value. Let me go ahead and run it, then I will explain you the entire loop. Okay, so as I said, first it will pick the object laptop, then it is going to do 1200 into 5, it is going to give you 600. Then it will pick a phone, where what it is going to do is it is going to again going to multiply 800 into 10, and once it is multiplied, it is going to print that value over here. And this all value that you are getting, what I am doing over here is, so total inventory value I have kept 0. Every time in every loop, every iteration, I am adding that total to the total inventory value, and at the end I am going to display that. So first 6,000, second 8,000, third 3,000 for headphones, fourth tablet 2,400, and the addition of all of them is 19,400. That is how you can create multiple objects, and that is how you can use those objects in a loop. So now see what's next. So now let's talk more about how we can access attributes and method, like how we call them. So once we are going to go ahead and create objects, we can access these attributes and method using dot notation. So attributes are accessed by writing the object name followed by a dot, object name followed by a dot, then followed by the attribute name for the attributes, and methods that we define inside our class. So uh, they are called similarly, but with parenthesis at the end. This is how it is called, which is going to be object name dot method name and the arguments that we pass. So class attributes can be accessed either through the class name or through an instance of the class. So instance attributes and methods are accessed through specific instances. You can also modify attributes after an object is created, allowing object to change its state over time. You can also modify attributes, methods operate on specific instance that calls them, which is why instance method takes self as their first parameter. The ability to bundle data with operations that work on that data is a key advantage of OOP, making the code more intuitive and reducing the chances of error. Let's understand this analogy of accessing attributes and method with a good example. So in this example, we will start with class student, which is going to be our student blueprint. Inside that, we are having a class attribute, which is school name is equal to Python high school, which is our class attribute, which is going to be available for all the methods inside the classes, that is the instance method. And then we move ahead to the initializer method. In the initializer method, that is init self name and grade. Name and grade are the parameters that are mandatory parameters that you will have to pass when you're going to go ahead and create the object. Then it sets up the student's instance attribute. This is how we are setting the student's instance attribute. So first we are going ahead and saying self.name is equal to name, self.grade is equal to grade, and self.course, it starts with an empty list for every object creation that we have. So each students can add their own course later. Right now, we are just creating the student's profile. Later on, we would be adding the courses as part of self.courses. Now, let's talk about the instance method. We have defined over here self.courses. Now I have defined add underscore course. So whenever I call the specific method, I will give the course and it is going to keep on appending them inside the courses list that we have, which was an empty list. And then we are using another method, which is going to calculate our GPA by dividing the grade by 20. So for example, a grade of 90 becomes a GPA of 4.5. So that is how it has been calculated. Now, what we are doing is, now we are going ahead and creating an object where we are passing two values, where I say student1 is equal to class name, and then the student name is Emma and the score is 85. Then I say print student1 dot name and grade for you to see that a new object is created with Emma and 85. Okay, so till now Emma and 85 is available. Now if you want to access the attribute, how you will do access a specific attribute inside the object which has been created. So we will say student1 dot name to get the name from that specific object. So when I say print student1 dot name, it has printed Emma. When I go ahead and say print student1 dot name, student1 dot grade, it is going to print the grade. Okay, now as I was talking in the PPT, I was showing you in the PPT, we can also modify the content or the value inside the object which is already been created. So it's not about only we are going to have we only can pass the values when we are creating the object. You can also change it when the object is created. So right now the student one is created and the previous score was 85, so we are going ahead and modifying it by 90, and that is how you do it. Student one dot grade is equal to 90. This is going to modify the grade, and if you see, the grade has been modified from 85 to 90 over here. Then if you want to access a class attribute, so right now we were accessing the instance attributes. So if you want to access the class attribute, this is how you do it. You will use class name and the attribute name, and it will give you the class attributes. Our class attribute that we have defined is this, that is school name. And when you did this, so with this pattern, class name dot class attribute name, you can access it. Now we are going to talk about how we can go ahead and call methods. So to call the method inside an object that has already been created, we can say student1 dot add course, and we are providing the course. So whenever I run this, it is going ahead and adding our courses into the list over here. So when I ran this code for the first time, the courses was a empty list. And when I said student1 dot add course, first time it appended this Python programming, second time it appended data science, and this is how the appended value looks like when you go ahead and access courses by saying student1 dot courses. So this is the instance attribute that we are accessing. So student1 dot courses is this. Then we go ahead and we get the GPA. So for getting the GPA, you can call the function that student1 dot get GPA. So right now the score was 90. So 90 divided by 20 would be 4.5. That is how your GPA was calculated. Now let's see what's next. But before that, what key takeaways we got from this? So we understood how we defined the class attributes that we already know. Instance attribute we defined, and the initializer, which was used as a constructor to set the values for all the instance attribute that we have created for each student. Then the instance method of add course and calculate GPA, how you can access all of them once the object has been created. So that was all about accessing attributes and method. Now again, one more very special concept and important, the self parameter. In Python method, it refers to specific instance that the method is called on. It's always the first parameter in instance methods. Through it's not a Python keyword, you could technically use a different name. By self is the standard convention that all Python programmers follow. The self parameter is used to access instance attribute with self dot attribute name. Call other methods with self dot method name, and distinguish instance attribute from local variables or parameters with the same name. This mechanism is fundamental to how instance method operate in Python, and is what allows different objects to maintain their own state. So the self parameter references the instance by using self keyword. It is used to access instance attribute, the instance attribute that we create. So whenever we use our constructor, in that we say self dot attribute name, right? So we are accessing the instance attribute that we are getting as an argument inside our constructor. Other way to call it is self dot method underscore name. This is how you can call the method names which are defined in the classes. This is also a way of calling or accessing the method inside a class. And so let's go ahead and understand this with a good example, that is self parameter. So over here, what we are doing, this is a temperature example. So over here, we are starting by defining a class called temperature. This is going to be our blueprint, which is going to help us create temperature objects that store Celsius value and convert them to Fahrenheit. So the initializer method that you see over here, it runs when you create a new temperature object every time, and the self.celsius is equal to Celsius, store the Celsius temperature as an instance attribute. So each object keep its own value for each object creation. So once we have defined our instance attribute, we are going to go ahead and now create methods. Those are going to be the behavior. So now the values that So whenever we create an object, we will say 25. Okay, then 25 Celsius. Now our work is going to be to change it to Fahrenheit, to set the temperature, to display the temperature. So these are the three behaviors that we would be working in this temperature class. So the instance method to Fahrenheit, it is going to use the self.celsius that we have created. That is the instance attribute that you see. Okay, and it is going to use the formula that is Celsius into 9 by 5 plus 32, and this shows how self lets you read an instance attribute. This is how you are reading a instance attribute, okay, by using self method. That is the beauty of using self method. In our previous example also, as I said, once we initialize the class, the values that we get, we are going ahead and creating the instance attribute by using the self method, by using the self keyword, and we use it everywhere in the instance method that we are creating. Then in the second one, what we are doing is it updates the self Celsius with a new value. So over here it says self.celsius is equal to Celsius. So whenever we use self over here, it is to modify the instance attribute to Celsius. Okay. Then in display temperature, what we are doing, so it is going to use self dot to sorry, it is not using self dot. Correct. Okay. So in display temperatures, what we are doing is it is going ahead and it is going to print both Celsius and Fahrenheit together. It is going to use self dot to Fahrenheit to call another method inside the same object. This is going to show how self is calling a method along with printing the value of an existing instance attribute that has been created. So in display temperature, what is happening? Fahrenheit is equal to self dot Fahrenheit. So in this method, by using self, I am invoking another method. So this 2 dot Fahrenheit, this line self dot this is going to invoke this, and this calculation is going to be performed, and it is going to be returned to Fahrenheit. Okay. So once this value has been returned to Fahrenheit, then I go ahead and I am going to use the default value of the Celsius which came in from here, self dot Celsius, and I am going to print Celsius degree is equal to the Fahrenheit. And if I go ahead and run this, so first time I have passed 25, then I am going ahead and saying temp dot display temperature. So it is going to invoke my Fahrenheit function, and once it is going to go ahead and invoke the function, then it is changing that 25 degrees Celsius to 77 Fahrenheit by using this formula. So as you can see that how we can use self to link between methods and the data inside the same object, and it also lets you access attributes. The way we access attribute was self.celsius. That was a way of accessing attribute. Then we changed the attribute. So over here in the set temperature, we are changing the attribute, that is the instance attribute, by saying self Celsius is equal to Celsius. This is the change. And the other one was calling other methods by using self. Here we changed, and here we called the other method, and here we used the value from the instance attribute. That is how you can use self keyword to do multiple operations inside these classes. So last but not the least, there are some object oriented design that you should be aware of. So object oriented is about creating effective classes that model your problem domain. So whenever you are defining a class, it is kind of your problem domain for which you are creating a blueprint, and several principles guide good OOPS design. So in OOPS design, what exactly we do is, the first thing is we do encapsulation, which is bundling related data and behavior together, keeping them organized and preventing unintended interactions. So let's take an example of our animal. So we actually went ahead and we encapsulated the data for all the animals, and the behavior that was animal dot speak. So that was the behavior. So we were encapsulating the blueprint. Inside the blueprint, we were encapsulating the behavior, okay, as well as the data which has been passed to create the object. Then the second one is abstraction. It hides the complex implementation details behind simpler interface, making your code easier to use. The single responsibility principle suggests that each class should have a single well-defined purpose, and providing an intuitive interface with clearly named method and attribute makes your classes more user-friendly. When designing classes, start by identifying the object that exist in your problem domain, what attributes each object should have, and what behaviors each object should exhibit. Keep your class focused and cohesive, avoiding the temptation to create God classes that try to do too much stuff. Don't make it more complicated. Keep it very focused and use docstring to document your classes and method, making it clear to others and your future self how to use them. So in many of the example, I have showed you that how we have used docstring for the classes, but it is a good practice to use that in the classes as well as the method that you are defining inside that classes. So our future self is able to understand that what exactly is happening inside inside this code. And this kind of approach leads to more maintainable, reusable, and understandable code. So thanks everyone for your time and participation. I encourage you to experiment with the concepts we discussed today. If you have any queries or thought, feel free to go ahead and drop them in the comment below. So these are the QR code by using which you can go ahead and scan it. Otherwise, I will also put them in the description below. Join our WhatsApp community, subscribe to our AIML channel and our Tech Insight Neuron newsletter. So see you in the next video. Take care and bye for now.